Hello students, welcome back to the Tantray physics classes. Today we will discuss a few more examples on pseudo forces, and it will be the fourth lecture on pseudo forces. And let us start with number one. Suppose we have a lift. It's accelerating upwards, and inside the lift there is a hanging pendulum or a bob hanging through a thread or through a string. We have to find what is the tension in the string. The cabin or the lift is accelerating upwards in the upward direction, something like this. It is a lift here, and from the ceiling there is a pendulum is hanging from the ceiling. It's a string and it is a pendulum of having a bob mass m, and this whole system is accelerating upwards with acceleration a0. And here is a observer. Is an observer here. Here is an observer whose velocity is 0 with respect to ground, and it is inertial frame of reference. Inertial frame of reference. Let me solve the problem with respect to this person, and later I will solve the same problem with respect to a person inside the lift. For a person who is accelerating upwards with the lift. That will be called as an inertial frame of reference. Okay, for comparison purposes, let me make that also here. It is an observer here, an inertial frame of reference. It is a lift accelerating upwards, and there is a bob here hanging from the ceiling. We have to find the tension here in the string. Okay. Now again, I will make the same lift here for clear comparison. Otherwise, I would solve this first, then that first, but in a very direct comparison, I want to show both the cases simultaneously, so that this will be very clear to you people. Okay, now again here, a lift here, same one, accelerating upwards with acceleration a0, and the string, a bob is attached to the string and to the ceiling, and it hangs downwards, and the person is now here inside the lift, right? He is also accelerating with acceleration a0, and I want to solve the problem for this person also. Okay, now for this person, what are the forces on the string, on the bob? The forces are mg downwards, tension upwards, and the net force on the bob is T minus mg in the y direction. But this bob, this object, this ball type, it is accelerating with a0 upwards because the whole system is accelerating upwards. So what are the forces for him? The forces are tension and weight is equal to mg. What is the net force? That is T minus mg is the net force. According to Newton's second law applied to the objects of constant mass, F net is equal to mass into acceleration. But here acceleration of this bob is a0. So here let us solve the problem now. F net is equal to T minus mg is equal to m a0. Now what about T? Tension is equal to m a0 plus mg. That is T equal to m common a0 plus g. This is the answer. So tension created in the string because when the lift is accelerating upwards, this tension produced in the string is m a0 plus g. That is T is equal to m a0 plus g. So tension will increase. Obviously, Tension, if the lift is stationary, then tension is equal to mg. But the lift is accelerating upwards, tension will increase. And tension is given by ma0 plus g. Let me solve the same problem for this. This person, what are the real forces for him? What are the real forces? That is mg, tension, real forces for this person for non-inertial frame. Inertial frame. Non-inertial frame, that is when the person is inside the lift and the person is also accelerating upwards with the lift with a0. So this person is a non-inertial frame of reference, I should call him. And now, what are the forces for this person on this bob? Tension, yes. Tension, B, weight, that's mg. These are real forces, which are always real for everybody, whether non-inertial or inertial. Now there's a third force, C. That force is what we call as pseudo force. Pseudo force is equal to ma0 in this direction. ma0. ma0. This is mg, this is ma0, because he will experience force on the bob opposite to his own acceleration. He is accelerating upwards and he will feel the force on this is downwards ma0. D, for the person inside the lift, the body is at rest. The acceleration of the body is 0, because it is acceleration. The acceleration of the lift is a0. His acceleration is also a0. So there is no relative acceleration. So the relative acceleration of this bob with respect to the person inside the lift is 0. So that means the object inside is not accelerating for a person inside the lift. So the bob is in equilibrium for the person inside. Person inside. A person inside the lift will observe that the bob is have 0 acceleration. It is not accelerating for him, because both the person inside and the lift both are accelerating upwards. There is no relative acceleration between the two. The relative acceleration is 0. So the bob inside the hanging bob inside the lift is in equilibrium for a person who is inside. So he will balance the forces. He will write T is equal to upward force called downward forces, ma0 plus mg. That is m common a0 plus g. Answer. So both will get the same answer, although both have different perceptions about the bob. The person outside the lift says the bob is accelerating upwards, and the person inside the lift says the bob is not accelerating. It is in equilibrium. But both of them will get the same answer for the tension. He says tension is equal to m a0 plus g, and this person also says the same thing, that T is m a0 plus g. That's all. That was first example. Second example. Second example on this pseudo force. Second example. Let me take this water tank or a beaker, or a container contains water having this much of level. Water level is like this. Okay, this is the water level up to which it's filled. Now let this water tank or this container start accelerating with a0. So this water inside, in order to give it an acceleration, there must be a force in the forward direction. So that force comes about when the water rises a little higher from this side. So the shape of the water will be like this now. Shape of the water will be like this. When it is accelerating, it will be like this. Because the person here, he feels there is force on this water tank in the backward direction, because he is also accelerating in the forward direction with A0, who is on the water tank. He will feel the force on the water inside in the backward direction, and the water will rise from this side, and it will go on rising until it becomes in equilibrium for a person. The water level has to remain in equilibrium. The water level has to remain in equilibrium with respect to a person who is on the water tank. So this is a water tank. It accelerates and water pushes in the backward direction because of the pseudo force, and it rises like this. When it rises like this, it will continue to rise unless the water level is in equilibrium with respect to the person who is at the top of the water tank. That is all. If you allow me to repeat like this, have a look. This is a water tank. It accelerates in this direction. Water will feel a force in the backward direction, and water level will rise, and it will continue to rise till the water level is in equilibrium with respect to the person who is on the top of the tank. Okay, now see here. What I have to find? I have to find this angle theta, through which angle the water level will shift upwards. Okay, let me take a water element here. Water element here. What are the forces on this water element here? According to this person, according to non-inertial frame of reference, backward, that is MA0, downward, that is mg. If the water element that you are taking is m. Under these two forces, the net force have to be perpendicular to the water surface, so that the water surface is in equilibrium. You must know, students, that if there is a water surface, if the force is perpendicular to the water surface will remain in equilibrium under this force. If force is not perpendicular to the water surface will not remain in equilibrium. It will tend to flow. Something like this. If you are it's a water surface, and if force is like this or force is like this, the water surface will remain in equilibrium, because this force will not make the water to flow. If the force is like this is a water surface, and this is theta, this is force. Component of the force in this direction, F cos theta, will make the water to flow. So in order for the water surface to remain in equilibrium, the net force must be perpendicular to the water surface. If it is not perpendicular to the water surface, but makes some angle with respect to the water surface will flow. Something like that. It's a water surface. If I push the water like this, it will flow. If I push the water like this, it will flow. But if I push the water like this, there will be waves produced, but water will not flow. So water remains in equilibrium under a force which is normal to the water surface. So for this water surface to remain in equilibrium, the net force, the net of these two forces must be perpendicular to the water surface. The resultant of these two forces must be perpendicular, so that this water surface remains in equilibrium with respect to the person here. So this is theta. Now you can find tan theta. This is theta, this is 90, this 90 minus theta, so this is theta. And this angle, tan theta, this force by this force, this line by this line, perpendicular by base, that is MA0 by mg. M gets cancelled. So what is theta? That is tan inverse A0 by g. Again, I could find it. How much angle the water surface will make with the horizon. These were two examples which I wanted to explain to the students, and the series will continue. Try to subscribe to my YouTube channel, Tantray Sir Physics Class. Also, there are many questions, lot of literature on this available on my app, that is Tantray Sir Physics class, which you can download from Google Store. Thank you.